So, this is a kind of supplement to our week 8 lecture 3, that is 24th lecture, in which we discussed principal axis or principal directions of a rigid body. And you know what this principal axis are. If you have x, y, z axis, then you have product of inertia terms and principal moment of inertia terms I x x x y etc. I x z like that. So, if all these product of inertia terms are 0, the axes are principal axis. So, that is kind of a definition, principal axis. And we had two simple ways to identify if a particular line is principal axis or not, and one was rotational symmetry axis, If you have a rigid body and origin is given here and you are searching for 3 principal axes with this origin, and you find that okay, here is a line which is a rotational symmetry axis. If you rotate this body about this line by an angle 2 pi by n integer and greater than 1, then this line will be principal axis. So, that we had given. Another was reflection symmetry plane. So, if you have a rigid body and you have a point origin and you are looking for principal axis of directions, and then you find that okay, there is a plane through this point which is reflection symmetry plane. If you reflect the whole rigid body in this, the mass distribution does not change, and then you say that okay, any line perpendicular to this plane is a principal direction or principal axis, can be taken as principal axis. Now, the supplement I want to discuss today is that the choice of origin is not to be forgotten. You first choose the origin and then look for all these axes. Otherwise, if you shift the origin or you do not think of the origin, a particular line, whether it is principal axis or not, that cannot be guaranteed. So, I give an example. Our example of this rectangular plate with some length L and some width B, uniform rectangular plate. So, we had seen that if I take this as the origin and then if I take this as y axis, this as x axis, and then we calculate, and the z axis is here, and then this is rotating about that y axis, that we had done in the lecture, that if it rotates this way with a uniform angular velocity, L is not parallel to angular velocity vector, angular momentum vector is not parallel to that, the torque is equal to I alpha does not work, because this is not a principal axis system. These 3 axes are not principal axis system, and you can see that I x y is not 0. X and y are always positive, and therefore, that minus m I x I y I or integration d m x y, that will not be 0, and therefore, all those things happen. But if the rotation is about z axis, then everything works well, because this is a principal axis. From this point, this is a principal axis, and that reflection symmetry plane works. This whole plane itself is a reflection symmetry plane, and this is perpendicular to that. Okay. But now I give another example. So, this is not principal axis direction, this is not principal axis direction, this is principal axis direction. Now, I give another example, that same plate, the same plate, and I take the origin here. Suppose this is the origin, and then this is x axis and this is y axis and the z axis is like this. Now, if you calculate that product of inertia term, z is 0 everywhere. So, I x z and I y z, these will be 0, and I x y is also 0, because you take any y, any element here, and then if I take a corresponding element here, then that minus m I x I y I, you can write in integration form also. So, for this element here, it is x into y, and for this it is x into y. Y is same, positive, but x is negative here, here and positive here, and so pairwise this term will vanish, and that can be done everywhere. You can distribute these pairs here, 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 here and so on. This entire thing can be thought of, made of such pairs, and I x y is also 0. So, this is a principal axis system. So, this line, think of this line, this is not a principal axis here, this is not a principal axis, this x axis, the same edge is not a principal axis here, but it is a principal axis here. Okay. So, this is important. If I from this origin, if I take this as the plane, right, this as a plane. So, in that plane if you reflect, that plane is a reflection symmetry plane, and lines perpendicular to that from any point, from here, from any point will be a principal axis. If your origin is on this plane, if the origin is on this plane, then you can draw the perpendicular, and this is a principal axis. But here that is not the case. This plane is not reflection symmetry plane, this line is not perpendicular to that, and it is not, the same line is not a principal axis direction here, the same line is principal axis direction here. So, do not forget to first choose origin and then look for the principal axis from that origin. So, that you can add to our lecture 8 and week 8 and lecture 3.